Hi everybody, this is Mr. Strickland.
And Miss Holtz, and today we just wanted to talk a little bit about vectors. So we already know some things about vectors. We've talked about the definition of a vector, and we know that some quantities are vectors such as velocity or displacement or acceleration. But now we're going to start talking a little bit more about drawing vectors.
So just to remind you what the definitions are, a vector is a quantity that's fully described by both a magnitude and a direction. And you guys need to remember magnitude just tells you how much of something. Vectors can be represented pictorially with arrows.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So we know that the length of a vector, we know that magnitude tells us how much there is of something. So when we want to draw that pictorially, we talk about that in terms of length. So let's say we have a car traveling at about 30 miles per hour. So we can represent that by an arrow to the right, because its velocity is going to the right, let's say. And we have a bike, and let's say it's traveling half the speed of the car at 15 miles per hour. So that arrow would be half as long, because the length describes how much of something there is. So we said this one was 30 miles per hour, and we said that this one was 15 miles per hour. So you can see that the length of the arrow tells us how much we have of something. It tells us the magnitude.
And these are handy because the diagrams help us understand the problems that we're working on. And these vector arrows just help give us a good way to visualize the motion of the object that's in question.
Now we can describe the direction of a vector in several ways. So we talked about the magnitude. Now we're going to talk about how to do the direction on our pictorial representation. So we can talk about the direction in terms of left or right, like we did in the last example. Or we can talk about them as up or down. So if you threw a ball into the air or something like that, you may describe your velocity as up or down. We can also describe direction in cardinal directions, like north, east, south, and west. And we can also describe direction in terms of polar coordinates using angles.
Well, before we go, give an example of cardinal directions.
So in terms of cardinal directions, we can think of it as the compass rose. So this is north, this is east, this is south, and this is west. So if you have a plane flying northeast, it would have an arrow that looks kind of like this. So it's going northeast. So let's go into a little more about polar coordinates. That's mostly what we'll be using in this class. So the angle is measured counterclockwise from the positive x-axis. That sounds kind of technical, so we'll debrief that a little bit. So,
All right, so where is 0 then, if we're looking at this?
Yeah, so let's think about this right here as the coordinate axis. So this is our x-axis right here, and this is our y-axis. So it says an angle is measured counterclockwise from the positive x-axis. So this is positive x, and we're going counterclockwise, going that way. So our angles are measured around this way. So this angle has 0 degrees right here. This is 0 degrees. And as we go this way, this would be a 90-degree angle. So our angle is between this axis right here and this axis right here. That's 90 degrees. Sorry for my terrible drawing there.
Hey, it works.
Yep.
All right, so how would we put a vector arrow in there? How would that work?
So if we wanted to see if we wanted to look at a vector that has a 90-degree angle, this would be an example of that. So this vector has some magnitude. We don't know what it's representing right here, but we know that its direction is 90 degrees because it's pointing straight up along the y-axis, which is 90 degrees from the positive x-axis. So let's do another example. We have an arrow that's pointing northeast, but if we want to talk about it in terms of degrees, we would measure it just like the last one from the positive x-axis. So this circle has lines marked every 15 degrees. So this line is 15, plus another 15 makes 30 degrees, plus another 15 makes 45 degrees.
And this is common, like if we have pilots that are flying, let's say you got a fighter jet and they have to go intercept something. Well, they might tell them they have to fly on a heading of 45 degrees, and that's what this would represent.
Oops. Okay, I was gonna write that in. So this is 45 degrees. Okay, now what about this vector right here? We're gonna measure it the same way. Even though it's not inside of this first quadrant here, we still measure the angle from the positive x-axis. So from here to the negative x-axis is 180 degrees, right? Because it's a flat line, this angle here. So it's going to be 180 plus this extra 15. So this entire angle right here is 195 degrees.
All right, great. So this is a quick explanation of an introduction to vectors. They have magnitude and direction, and that can be represented by the arrow. We will get into this in further detail in upcoming videos and in class, but maybe this gives you the basic ideas to get us started.
Thanks, guys.